Lab 3 experiment will be about free fall. And the purpose of this activity is to measure the acceleration due to gravity of a falling object. For example, pick something up with your hand and drop it. When you release it from your hand, at that instant, its speed is zero, right? When you drop it, on the way down, its speed increases. And the longer it falls, the faster it travels. And this sounds like acceleration because it is accelerating. And this acceleration was the result of gravity. It's due to gravity. And it's a free fall, and free fall occurs whenever an object is acted upon by gravity alone. So in this experiment we are going to use a motion sensor, the Capstone software, 3 balls of a varying mass. We are going to drop the balls and let them bounce several times and record that in Capstone software. Then we are going to analyze the slope of position time graph, the slope of velocity time graph, and the area under the velocity time graph. So I've done the experiment for you, and I'm going to provide you with the Capstone raw data file so you can use it. This is how the position time graph would look like. Okay, we should have at least 2 good curves. You will be provided with that. So then we're going to go through the analysis. Okay, this is the position time graph. This is the velocity time graph. Notice that the position time graph, the slope there gives me what? You remember from last experiment. Okay, let me grab the whiteboard. Okay, in the position time graph, so this is the position or displacement, distance, time graph. Okay, the slope is what? Rise over run, right? So it is d over t, which is the equation of what? The velocity. So the slope and of the position time graph is the velocity. Okay, look, meters per second. Displacement gives me meter. Time gives me second. Meter per second is velocity. Okay, what about what about the velocity time graph? Okay, that looks like this. Okay, what's the slope here? Okay, now again, this is linear, so the slope is rise over run, so v over t, so meters per second divided by second gives me what? You push this denominator down, so gives me meters per second times second square. And what is this? Acceleration, right? Okay, so first we have a rubber ball, and we dropped it. This is the sensor here. Okay, and the height is just over 1 meter. Okay, and the second one is a golf ball. And the third one is a ping pong ball. So this was the experiment. Okay, and hooking it up is really easy. You just connect, you mount the sensor, get the 3 balls ready, open Capstan software, connect the sensor to the USB link and to the USB adapter and the USB adapter to your computer. Okay, follow the steps here. Okay, and now we have to do some analysis here. So this is the Capstan software that, or this is the Capstan data file that you will be provided with. And notice here that I have a rubber ball. I don't have run 1, 2, 3. By the way, you can rename them from here. Click on data summary. And in the previous experiment we had run 1, run 2, run 3, which was slow, medium, and fast motion. Just double click on it and rename it. Okay, and it will reflect it here, here, and here. Okay, so for the rubber ball, this is how it bounces. For the ping pong, this is how it bounces. And notice the rubber ball is still in the background, which is fine. Okay, and the reason is because it is selected here, still selected here. Now let's go with the golf ball. Okay, and selected automatically when I chose golf ball from here. So run this. Okay, so you can see the 3 of them here at the same time. So let me just deselect all, select the rubber ball from here. Okay, put it back to 0, and let's start with the analysis. Now it says the graph screen shows a mirror image of a ball bouncing on flat surface. On the position time plot, the ball is at the top of its flight when it's closest to the motion sensor. Makes sense. And the ball is at the floor when it is farthest from the motion sensor. Okay, and this is the position time graph. Now here, notice in the velocity plot graph that the velocity of the ball is positive part of the time above the x-axis and the negative part of the time below x-axis. So the motion sensor here records motion away from it as positive and motion towards it as negative. So when it's going down, it's a positive. When it's bouncing back, it records it as negative. Okay, so we are going to start with the position time curve. Okay, and find the slope there at 1.2 seconds, and we are going to use the coordinates tool to show the values. I'll show you in a minute what it means, and then we are going to record our findings in these tables. So 1.2 seconds, I have a different Capstan file, different data, and I'm going to show you one example here. I'll do it for 1.5 seconds, but you're going to do it for 1.2 seconds. Okay, and this is different than a different file, different data than the file I'm going to provide you. This is just to show you the example. So let's start by centering this, auto scale it from 0 here. Now, so at 1.5 seconds here, okay, I'm going to select this point. Okay, so select this point. These will pop up. Click on the slope. It will show you the slope. Okay. Okay, now we are going to click on this icon here where it says add a coordinates tool, and choose the first one. Okay, and grab it to the 1.5. Okay, and this is the coordinates we're talking about here. Okay, use the coordinates tool to show values. Okay, so at 1.5 seconds the height was 53 centimeters and the velocity or the slope was 2.41 meters per second. So you are going to come to this table and type in, what was it here, 2.41 meters per second. Okay, I'll do this for 1.5. Okay, now we're going to find the velocity at the corresponding time from the velocity time curve. Okay, and grab this. Okay, minimize it like this, not minimize it, but make it smaller. Click on these three dots. Okay, and I'm going to grab and drop a graph here. Okay, and select velocity. Then click on the scale button here. And I'm going to click on this tool, the coordinate tool again. Select and look for 1.5 seconds. Here it is. Okay, go up, go down, the value changes. You're looking here. Okay, let me zoom in a little bit. Okay, look here, go up, come here. Okay, so I'm looking for this point here, 1.5 seconds, and the velocity, and what it's asking, they want the velocity from the velocity time curve here, okay, which is 2.41. Okay, do you notice anything here? Okay, so you are going to do this for at 1.2 seconds from the other graph for the three balls, and you will be done with table 1.